Are SRE and DevOps the same? Definitely, some of the most common terms that generate confusion among IT engineers in the current times are SRE and DevOps. Are those part of the same scope? Do they have the same responsibilities and job description? Hi, I'm Sergio Garcia, and today we're going to talk about SRE versus DevOps. Are you ready? Before we start, subscribe to our channel for the latest threads, tools, and best practices in the thriving world of DevOps and software development. Now, let's get into it. What is a Site Reliability Engineer, or SRE? By definition, an SRE engineer or Site Reliability Engineer integrates the software development and operations team activities, ensuring system reliability and availability improvement. At the same time, an SRE engineer takes responsibilities related to operations, taking care of the incident response, SLAs, performance issues, downtimes, and infrastructure health. What is a DevOps engineer? Now, talking about SRE versus DevOps, if SRE are troubleshooting experts, DevOps engineers are the integrator-in-chief. We can define a DevOps engineer as the one in charge of designing the integration between development and operations, using the best choice of tools to provide infrastructure over the cloud, setting up an environment that contains the desired application running on it, and automating the procedure that builds these applications using CI/CD pipelines. DevOps Responsibilities. What exactly does a DevOps engineer do? Depending on the client necessities, a DevOps engineer can take care of multiple activities related to different topics like security, monitoring, disaster recovery, plans, cost savings, and performance improvement, applying automated procedures to provide these results to each client requirement. At first sight, when it comes to SRE versus DevOps, you can determine that some activities are shared between both positions to reach the common goal. But here is a way to better understand the workflow between both roles in a project. For example, assuming we are developing and launching a new web application, the DevOps team handles the application design, development, and infrastructure configuration. At the same time, they ensure the success of the deployment procedure to the different configured environments, creating a way to validate each new change over this app to the final stage, the production environment. SRE Responsibilities. Is the work done at that point? No. An SRE takes over from there and ensures that the infrastructure properly functions, enabling the application to deliver better performance and high availability. Firstly, they need to create service level objectives or SLOs to measure the system and site performance by running the application under normal operating conditions and nothing the performance levels. Then, run the application under heavy loads to identify the acceptable performance degradable level. Once that is defined, the service level agreements or SLAs must be prepared based on the results obtained from SLOs. These are also used for reliability work, prioritizing correcting performance issues that do not meet the SLO level instead of optimizing the performance on an app running at the SLO level. While a DevOps engineer designs and implements DevOps in an organization, an SRE sustains it to deliver optimal performance. While the former slightly leans to the dev side of DevOps, an SRE loves the ops side of DevOps. This is where both roles stand in this SRE versus DevOps battle. Are you working as an SRE? What do you enjoy the most about your role? Let us know in the comments. DevOps Tools. Talking about what DevOps does, we are normally helped by different tools to reach our goals in our projects. For example, most cloud servers, mobile phones, web servers, and operating systems are powered by Linux kernel. So, installing Linux distribution on our computers is very common. This is helpful to perform activities like building and compiling code, installing and configuring software, running, monitoring, and managing applications and processes, managing users, groups, and permissions, server setup and management, and using scripting tools to automate procedures. Scripting tools. Talking about the scripting, most DevOps started using Bash scripting since it's the language managed by operating systems that we frequently use. Still, Python scripting is currently more popular and helpful because this programming language offers scripting and can also be used for automation and app development. It is best suited for scripts that comprise thousands of lines of code using libraries and objects that perform complex tasks. CI/CD tools. Related to automated procedures, a DevOps engineer ensures that the new code changes can be automated and secure to the operational servers. That's why they implement a continuous integration and continuous delivery procedure, or CI/CD. Not only to ensure this procedure can be done correctly, but they are also in charge of training the team into a new code delivery strategy, including releases per specific periods to ensure untested changes or anything else is not deployed into your production application. There are 3 popular CI/CD tools for DevOps engineers. Jenkins is very common to hear because it's preferred for the automation of CI/CD pipelines by many DevOps engineers. This open source tool offers a versatile ecosystem with hundreds of plugins and higher extensibility. Circle CI is another popular CI/CD platform designed to manage and scale complex CI/CD pipelines efficiently. It is easy to set up and use and does not require a dedicated server to perform CI/CD tasks. Still, it is only available for GitHub and Bitbucket repositories, and you must pay after you reach the deployment time limit they offer. GitLab is an open-source CI/CD engine built on Git with enterprise-grade security capabilities. Integration and implementation of this tool are easy, and it is a robust tool that seamlessly integrates with Docker. However, advanced features are only available for ultimate users. Microservices and containerization tools. One of the most common ways to integrate and follow the DevOps cycle is to migrate your application into a microservices model, to divide your application into single components that can be built just when new changes related to those parts are needed, decreasing the time that is used to make a package of your application and the delivery times of these new changes. Commonly, Docker is our best option since it helps us to isolate each part of an application and deploy it in less time than other known procedures that could imply more time to build an entire solution when you just did a change in a single code line. This strategy needs to include container orchestration to maintain your application, using services such as ECS or EKS to maintain your application based on microservices is the best option for you. And those services were created with that purpose, and they are flexible for using different deployment strategies to ensure you don't have downtime during your process. Infrastructure as code tools. As your application will be deployed into any cloud you choose, we can't ignore one of the most common procedures to provide infrastructure in an automated way: infrastructure as code. This is another practice where DevOps engineers employ some interesting tools. For example, you can use AWS CloudFormation to create your entire cluster, primarily focus on AWS services, or use Terraform to create the new infrastructure and support open source. Both services are free, but Terraform is a multi-cloud infrastructure as code tool, so you can use it for different cloud providers. Normally, Terraform is used along with Ansible when you need to perform specific configurations inside a newly created infrastructure, and it's helpful when you are following an entire deployment model based on infrastructure. This is because it can help with the application deployment and configuration management, offered to customers as Ansible automation platform. One of the advantages of Ansible is that it is an engine-less tool, which means DevOps engineers don't have to install anything to make Ansible do its job inside the new infrastructure provision. What are your favorite DevOps tools? Check out this video about the top tools used for automation in DevOps. Now let's talk about SRE tools. You will notice that some tools are related to others we mentioned previously, but have a different scope. Application Performance Management Tools. We can start with Application Performance Management Tools, or APM. These tools ensures that apps and sites are available and deliver optimal performance. An SRE uses an APM tool to monitor the application against predefined metrics, collect app performance metrics, and analyze them to identify potential issues and set up a system to alert the concerned people for a quick resolution when the baselines are unmet. Regarding popular APM tools, we can find Datadog, one of the most popular application performance monitoring and observability services in the SRE market. This SaaS-based tool enables SRE to monitor containers, hundreds of OSES, web apps, mobile apps, and cloud hosts while displaying results in visually appealing graphs, charts, and rolling timelines. New Relic is another useful tool because it enables SREs to monitor services operators, hardware and software performance, and user interactions on the web and mobile apps. This tool is best suited for monitoring application performance and is highly extensible with rich, RESTful APIs. If we want an open source option, Kibana is a popular data visualization dashboard software that SREs use with the Elasticsearch Analytics engine. You can analyze data in real time and determine potential issues in your infrastructure since it has an intuitive interface and flexible visualization options. It normally comes as a product suite in Elastic Refer to see ELK Stack, Elasticsearch, Logstash, and Kibana. Automated incident response systems. One of the most critical activities that we need to keep in mind is the procedures that we can automate in case that something is not correct on our side. And that's one of the key responsibilities of a site reliability engineer. Automated incident response systems help SREs to manage infrastructure with ease. As the name suggests, AIRS perform vulnerability scans to detect, analyze, and generate actionable threat intelligence automatically. As such, SREs can quickly respond to incidents and remediate risk, thereby saving time and costs. PagerDuty is a popular automated incident response system that works as an alarm aggregator, collecting all alarms for monitoring services and tools to provide SREs with comprehensive visibility into infrastructure operations. With a centralized view, SREs can eliminate duplicate alerts, customize and filter alert notifications, and reduce time to repair. It supports voice calls, SMS, push notifications, and emails. Configuration Management Tool. Previously, we mentioned tools like Terraform, CloudFormation, and Ansible for infrastructure as code purposes. But these tools can be used as configuration management tools for an SRE engineer since they automate the previous tedious process of identifying, tracking, and documenting changes in devices, software, and hardware across the infrastructure. Simply put, CM tools allow SREs to maintain every system in its desired state. To recap, a DevOps engineer uses these tools to execute infrastructure as code tasks, and an SRE engineer uses them to execute configuration management tasks. In addition to this, DevOps engineers use these tools for infrastructure setup and provisioning of infrastructure resources for app development. In contrast, an SRE engineer uses them to asset discovery and storage of specs and config records, version controlling of apps, tools change approval, history of changes, etc. Scripting tools. Bash and Python scripting are used by an SRE as well, mainly for administration tasks. For instance, a site reliability engineer can create a script to refresh the memory of a specific device at the end of every day or a week, turn off unused VMs or other cloud resources, back up specific data, or perform routine maintenance tasks. Server management tools. If we mention servers management for an SRE engineer, it mostly deals with infrastructure administrator tasks and works with massive servers at scale. Therefore, a key requirement for an SRE is a thorough knowledge of operating systems and different flavors of Unix, such as Ubuntu, Debian, Linux, CentOS, etc. Are you a DevOps engineer performing SRE activities as well? Tell us in the comments about your experience on this. We went through a lot of information to solve the SRE versus DevOps debate today. So let me conclude with this affirmation. As DevOps evolves, organizations are getting to know the true potential of this methodology. Understanding the SRE versus DevOps differences is the key here. For smaller organizations with 2 or 6 DevOps engineers, a DevOps engineer usually performs the task of an SRE. But the difference can be better noticed when you work in a large enterprise wherein 10 or more DevOps engineers are available. All the tasks are divided between the DevOps engineer and the SRE. Similarly, when they launch a new product, a DevOps engineer will initially handle the entire product lifecycle. After successfully releasing the product, the SRE will take over and ensure high availability and reliability. Visit our blog SRE versus DevOps, which includes detailed information about all the concepts I've described today, along with diagrams that can help you visualize the big differences between these two roles. Also, don't forget to like and subscribe to our channel to be updated with our IT information. I'm Sergio Garcia, and I'll see you in the next video.